Hello viewer, today we will discuss the important formulae in structural analysis 2. While solving the numerical, we require the fixed moment in the various numericals. So we will discuss with the various conditions where what will be the formulae for that particular fixed moment. So when our first condition is here, a fixed beam carries centrally point load W acting at a center. So what will be the fixed end moment at this A and at this B? Okay, so that we have to discuss. So we consider first moment is anti-clockwise, second moment is clockwise for a particular span. Okay, so now our clockwise moment will be the positive and anti-clockwise moment will be the negative. So what happen in this case, the first moment will be always negative and second moment will be the positive. So what will be the fixed moment when centrally applied point load at a particular span AB? So it will be WL by 8, WL by 8. But first moment is negative. When we go for A to B, at that time your moment will be the negative, and we go for B to A, at that time your moment will be the positive. Okay, so remember this formula. Here we will get idea about fixed moment when the centrally point load is acting. What happen when the point load acting at eccentrically? In first case we see that the point load is acting at a center, so formula will be WL by 8 minus in the first case and negative plus in the second case. If in same way the point load is acting at eccentrically, that means the W is not at a center, so what will be the fixed moment? The fixed moment will be W is the load AB square, A and this B square, divided by whole length square, that is L square. First moment is negative because it rotates anti-clockwise, second moment will be the positive. So in the second moment at B will be MFBA, that is WA square B upon L square. Here AB square, here A square B. So remember, this is very confusing formula when most of the students getting incorrect answer in this case, because of they are not aware about where is the square. So remember, this is very important things. W here first moment will be B square and second one is the A square. First will be negative, second will be the positive moment. Okay, remember this formula, it is very important. What is mean by M? M means a moment, F means fixed moment, fixed, and AB means when we taking the moment from A to B, that will be the minus. MFBA means B to A, so MFBA means B to A. Okay, so no, it B to A. Okay, so this will be the nomenclature for a particular structure. Okay, let us go for the another one. See, in this case our second case is when UDL is acting throughout the span, uniformly distributed load W kilonewton per meter acting throughout the span. What will be the fixed moment at A and what will be the fixed moment at B? Remember, this is very important formula. WL square divided by 12 is the formula. WL square divided by 12. First moment is anti-clockwise, that's why negative. Second one is the positive. Okay, so this is very important formula. Most of the numerical in that there will be the load of UDL is present, so you require this fixed moment. So remember, WL square divided by 12, and this formula already we proved in structural analysis 1 in second year. So you should only remember this formula in structural analysis 2 in third year. Okay, so what happened when this UDL is acting to the half span? In previous case we see that when the centrally W is acting and eccentrically W is acting. In this case, similarly, in this case when the UDL is acting half of the span from left side or right side, whatever the sides. So in this case, first moment will be the negative, that is 11 WL square divided by 192. 11 WL square divided by 192, and in this case it will be the plus WL square divided by 192. Remember, this is also important formula. When UDL acting at particular half span of the beam, particular half span, that means suppose your AB span is carrying UDL at half up to the half span. So what will be the fixed moment? It will be the minus WL square at 1 divided by 192 at A, and plus because of the clockwise moment, it is 11 WL square divided by 192. Okay, so now our third case is here. See here, when the fixed beam carries uniformly varying load UVL of W kilonewton per meter is acting throughout the span AB. See here, it is very interesting formula to memorize. When this type of load is acting, so what will be the fixed moment at A and what will be the fixed moment at B? So in this case, WL square divided by 30, when see that the apex point of the triangle is where? This is the apex point, this is the base. Okay, where is the apex point? At that point you will be the dividing factor will be the more, and where will be the base, where the dividing factor will be the less. So see here, in this case WL, here is the factor is more when the apex point is there, and at the base it will be the dividing factor will be the less. So remember how to remember the formula. WL square divided by 30, WL square divided by 20. First will be the negative moment, second will be the positive moment. Okay, these things there we have to remember. But where will be the dividing factor is more? When the apex point is there, so dividing factor is more. When the base is there, so dividing factor is less. Okay, so what happen when this type of structure is there? So in this case, see here, in this case the apex point is here, so here your fixed moment will be WL square divided by 30, it will be the plus, and here WL square divided by 20, it will be the minus. So remember these things. So apex point, where will be the apex point? That will be the more value to divide in dividing factor. So then another type of UVL is there. When this type of UVL is acting on structure, so what will be the fixed moment? So this will be the symmetric UVL. In previous case that will be not a symmetrical. So in this case, see that the centrally we get the symmetric triangle over the structure, so loading condition is same, so fixed moment will be the same. So that is 5 WL square divided by 96, it is negative, and here positive will be the 5 WL square divided by 96. Okay, so this will be the fixed moment when the UVL is there. So you see that the first case UVL formula will different, and in second case the formula will be the varies. So remember which type of UVL is acting, at that time you have to consider the particular formula, otherwise you will get the wrong answer. So when the triangle not a symmetrical triangle, at that time 30-20 concept is there, and when the symmetric triangle is acting, that time 5 divided by 96 concept is there. Okay, so now come to this important formula. See here, when the fixed beam carries moment as a loading, it means that the somewhat percentage of actual moment is acting on a particular span. When the moment is acting on a particular fixed beam, so what will be the fixed end moment? So that will be the m by 4, that will be the m by 4 at both the case. See here, in this case sign convention is different. When the clockwise moment is acting, at that time you have to consider both the moment positive. When the anti-clockwise moment is acting, so in this case your formula will be the negative. So already written here, the anti-clockwise moment sign will be the negative for both the cases. In this case your moment is rotating clockwise, so that means fixed moment, both the fixed moment will be the plus. When it is rotating anti-clockwise, so and in that case your both the moment will be the negative. So remember these things. Most of the students getting wrong answer in this case because of they are consider first is minus, second one is plus, because they know that first moment is anti-clockwise, but we are calculating the moment because of this actual moment. So in this case you have to remember the sign convention depends on this moment, acting moment. So it is clockwise, but when it is acting at a center, it will be the m by 4. What happen? It will acting at eccentrically, so the formula will be the different. So what is the formula when the moment is acting at outer side, or it means at eccentrically to the particular span? So first distance is A, second distance is B. So what will be the fixed moment? In previous case we consider that it will be acting as center, so it will be the m by 4, but in this case it will be m into B. This m is moment, this B is the second distance, into bracket 2a, 2 multiplied by a minus b divided by L square. In second case it will be the ma opposite. In this case mb था, यहाँ पे ma into bracket 2b minus a upon L square, it will be the formula. So remember this is also one of the important formula to for calculating the or solving the numerical. So here also plus sign is used, here is also plus sign is used. Why? Because of our movement is acting clockwise. So if this movement is acting like this anti-clockwise, so your movement, both the answer will be the negative. Now last important formula is here, that is when the sinking is there, somewhat percentage of sinking is there. So delta is the sinking. Suppose this is the beam, it will sink down, that means lower down. So at a particular length, we can say that it is delta, indicated by the delta, and it will be in the mm. So what will be the fixed end moment when the sinking is happen? So that fixed end moment will be, see in this case, it will be 6 EI delta upon L square, 6 EI delta upon L square. So see here, when the continuous beam is there, two or more span is there, and in between the particular member joint is displaced at a particular distance, so we have to consider the sign convention. When suppose this is the beam, here the central B point is sinking, at that time we have to consider the sign conventions. When the B is acting sinking downward at a particular distance delta, so in that case BA and AB movement having different sign convention, and BC and CB having different sign convention. We will discuss it later. Okay, so this is the important formula related to the fixed end moment. So once again we revise the formula. What is that formula? When the central point load is acting, that is WL divided by 8. When the eccentric point load is acting, WAB square upon L, WA square B upon L. Here we have to remember A square and B square, where we have to use the A square and B square. Then UL is acting, UDL is acting, WL square divided by 12. When UL is acting, WL square by 30, 20. Remember apex point 30, base point 20. Then symmetric UDL is acting, UVL is acting. So triangle, that will be 5 divided by 96, minus in first case and plus in second case. Then 11 divided by 192, when half span carries the UDL. See here, moment at the center, so it will be m by 4, m by 4. Moment at the eccentric distance, it will be the mb into b 2a minus b upon L square at A point, and at B point it will be the ma into 2b minus a upon L square. Now when sinking is there, so it will be the 6 EI delta upon L square, but sign convention that we have to consider. Okay, so these are the formula related to the fixed end moment. Now we are to discuss one important thing also, free end moment. What will be the free end moment? It is also one of the important things. When we have to draw, we are going to draw the diagrams, that is bending moment diagrams, that is free end final bending moment diagram. At that time we require these types of shapes to draw the free final bending moment diagram. That means we have to superimpose the free bending moment diagram on the final bending moment diagram. So at that time you have to consider the particular shapes and their values. Okay, so what will be that particular shape that we have to discuss? That shapes are when the free end, that is free beam, carries centrally point load. So what will be the free bending moment diagram? The shape is like triangle, and the formula that maximum bending moment will be the free bending moment will be the WL by 4. When eccentric point load is acting, so diagram will be varies where the point load is acting, at that point having the maximum bending moment, and that will be the WAB square upon WAB upon L. Also when the UDL is acting on a particular span, so what will be the free bending moment? That will be the like a second degree parabola, and it will be the WL square divided by 8. Free bending moment diagram will be the WL square divided by 8. Now when the particular moment is acting on the structure, this is very important, clockwise moment is acting. So see here how to draw the bending moment diagram when the clockwise moment is acting. See here, this is a plus sign. When clockwise is acting, upper portion will be the topper and lower portion will be the right portion will be the upper portion, and lower portion it will be on left side. When the anti-clockwise movement is acting, so in this case, see this is the right clockwise movement. Anti-clockwise केस में आप लोग क्या करेंगे, नीचे ड्रॉ करेंगे. So this will be the same thing. When anti-clockwise movement is acting, at that time this portion will be, left portion will be in the top, and right portion will be at the bottom. So different diagram is here. So what is the difference between clockwise and anti-clockwise? When we draw the diagram, this will be the clockwise, right side portion is upper, and when the anti-clockwise is there, so in that case this portion will be the left portion will be at the top, and right portion we have to draw at bottom. So also important things, when the centrally acting moment is there, so the free bending moment value will be the m by 2 m by 2. So here m by 2 at top, m by 2 at the bottom. Similarly, when eccentric point load is acting, so what will be the free bending moment diagram? So it will be the same. Anti-clockwise acting, so right portion, left portion will be the at top, and left portion will be at the bottom. So mb upon L, ma upon L. ma upon L is top, mb upon L is at the bottom. Similarly, when UVL is acting, that is symmetric loading UVL is acting, so what will be the, it will be third degree parabola, and value will be the WL square divided by 12, that is the maximum bending moment value. When UVL, that is apex and base type of UVL is acting, at that time the value will be the WL square divided by 9 root 3. WL square divided by 9 multiplied by root 3. This will be the value, and these are the shape that we have to draw while the final moment diagram. So once again repeat the things. When centrally point load is acting, that will be WL by 4. That will be the WL by 4. It is a free bending moment diagram value. When we previously we discussed the fixed end moment, this is the free moment. So don't confuse in your mind. Second thing is, when W acting at eccentrically, that value will be WAB upon L. UDL is acting, that value will be WL square divided by 8, and parabola is the shape. Centrally point load is acting and clockwise movement is there, so m by 2 will be the value of particular free bending moment, but the shape will be the right portion at the top and left portion will be the bottom. And clockwise there, anti-clockwise there, so I already explained that left portion at the top and right portion at the bottom. So anti-clockwise is here, and eccentric movement is acting, so ma upon L, mb upon L. Then this type of UL is acting, so in this case WL square divided by 12, and this type of UL is acting at the time WL square divided by 9 root 3. So this is the important formula and their shapes. So remember these things. Whenever you watch this video, you have to take the screenshot, because this is very important formula, and rememberize this formula. In next lecture we will discuss one numerical on slope deflection methods. Thank you for watching. Share this video, like this video. If any comments, so definitely ask any questions if you have. Thank you for watching.